Okay, what we have here is a variable coil. It's 26 turns of number 10 bare copper wire, they use for ground wire. It's got a knob on the top. This is threaded here, and it's got a couple jam nuts on the top, jam nuts on the bottom of the polycarbonate base, and then 3 attachments points for copper tube. And what we have is a barely see it. It's a 10K resistor here. The scope gets direct connection with the coil, and we go through 10K into the function generator, which just happens to be the BK 4040B. We just got it's 20 megahertz. This coil is a quarter wavelength for 13.56 megahertz. That's the power supply we're ultimately going to be designing for the Donald Smith project. I want to show you the relationship between basically the ground. If you have a ground plane, the best quality coil you're going to get is going to be the bare copper without any insulation in there. Higher quality, the more multiplication factor, whether you're multiplying voltage for a series LC tank circuit or amps for a parallel tank circuit. So the higher the quality, Q factor of the coil, the more amplification factor. So you're ultimately shooting for the highest quality when you're designing your coils. Bare wire is going to be a much better than insulated. When we get close to the bottom of this coil, if we touch it, you can see it shorts out quite a bit. The amplitude drops down. If we touch the top of the coil, it doesn't do much of anything. See, we get closer to the bottom, you lose more and more amplitude. But I also wanted to show you, when you get your hand close to this, you can just get close, it doesn't have to touch. We lose amplitude. So ultimately, when you design these coils, again, no insulation, and you want to keep enough clearance between the Faraday cage or box its coil is going to be in, so you can get the most amount of power out of this coil. So there you have it.